Welcome! We're going to talk about corporate computer security related to data protection from the Corporate Computer Security book by Randall Boyle. Chapter 9. Things we're going to learn here are the importance of securing data, how much data you back up, the scope of that data, and how it's done. Give you familiarity with RAID. Always talk about that with computer configuration. Policies about data storage. And we get into some details of database data protection. Ideas and techniques, current practices to prevent data loss. And of course, deleting data we don't need anymore. Data is easily overwhelms disk drives and systems because it's so easy to duplicate, and who wants to get rid of that in case you may need it later, like my garage. Data is everywhere. They're critical elements of many systems, and they decide what to spend money on, where to market product based on the data you have. Data mining is a huge area of science. Artificial intelligence, guess what? They use lots of data to train AI neural networks. They're valuable and they determine your strategy. Sometimes your company is simply selling the data. Now you have secrets, you have trade secrets, you have recipes, patents, all that kind of thing, source code for programs. That all needs to be protected, not only from being stolen by your competitors or enemies, but lost because of failure of the hardware. So you have to cover both protection from the computer crashing and disk drives crashing to someone walking out the door with your data. And it's so easy to forget that your physical hard drive is going to fail. It's not a matter of if, it is a matter of when. So keep that in mind. You're going to run that jump drive through the washer, it's going to be run over by your car, dropped it in the driveway. You are going to lose or destroy, or it's going to lose the capability to save your data. So do you have a way of protecting it? It's very easy to have backups. So we're talking about data that's being stored. We're not talking about data being transferred along the way. That's a whole networking issue, and we've talked about the whole encryption and secure networks and all that. We're talking now about the storage of the data in various forms. We want to prevent losing of the data, accidentally burning down the storeroom of data, the data farm, storing it securely so it can't be given away, taken away, and another way to not have it taken away is to, in an efficient and secure way, actually erasing data when you dispose of equipment. Most people realize it's very hard to erase data. If someone really wanted to get at your data, and you really didn't want them to, most people simply shred their old disk drives because data can be recovered unless you really erase your data properly. Anything not backed up is going to be lost. So how do you make sure that you have the backup happening? Plan on the host or the entire plant or building being burnt down. Is that data stored off-site in a secure place? I had a brother-in-law running a legal firm, in a small town. His office was attached to a restaurant, and that restaurant had a grease fire in the kitchen. Came back one day and it was burnt down. He had just happened to take the backup copies home. Normally he didn't, but that would have been lost. I think he did much better after that. That was way before the internet and lots of cloud backup options. He had 3.5-inch floppy drives. Some people can use your data. They can ransomware and try to sell it back to you. So The backup will not address the reason things got damaged. It just offers a way to recover it. You can set up backup under Windows. Macintosh, I'd say, has had the best thing around for many, many years. A thing called Time Machine, built into your system. And it would nag you if you hadn't had Time Machine configured. And it would basically say, hey, we need to set up a separate hard drive for us to have backups. And Time Machine, very user-friendly, very convenient. Windows is still trying to chase Microsoft and the friendliness of those things. But you can find ways to back up things. Servers have built-in backup. It's a little harder to get at with Windows, regular desktop version, but you can. Do a little exploring and find out. You just do a little Windows search on backup. You can decide what to back up. Your entire operating system, your entire system. Clone your entire system. That's the nice thing about virtual machines. Very easy to clone a machine. In the regular desktop, you can't back up the entire system. You choose the important folders because you're wasting your time backing up a lot of other things. You do want to know how you could re-image, reconstruct your PC, and then get your important files over to that other PC. You'll get better at this as you replace your PCs and realize, hey, what have I lost? What do I need? Oh, yeah, that's right. Maybe I should just get that old hard drive from that system. Lots and lots of files that I need there. Get a new phone. Oh, what have you lost with the new phone? Forces you to think about having those backups and what to do with that. What they mean about not good for programs. You don't usually need to back up your programs. You usually can reinstall them from the source drive. Unless it's a really, really old program that you have a really old version. Sometimes it's good to have that installation folders, those installation folders available to you, because sometimes a new version doesn't quite work so well. If the old version was working, you might want to make a copy. But usually you don't copy all your programs that you have in your system. The image backup, they call that the image. You're making a backup. You're making an image of everything on your hard drive. And typically you're going to a larger hard drive. It's not really super slow unless you have a very huge system, and hard drives are fast. So actually cloning or making an image is not horribly slow, but it is slower than just backing up what changed. Data, specific data that is changing day by day or hour by hour, those are the things that we would want to make sure we have backup of, because those are probably the files critical to our company. Shadowing is a term used for whenever I make a copy of something or whenever I use it or change it, there is a shadow copy automatically created somewhere. So you can set up shadow copies in your local disk, and you can decide where to save shadow copies, or you can manually create shadow copies. Some programs, like Microsoft Office, when you make changes to files, there are shadow copies automatically being created for you, something you can configure in that program. So Windows can be doing it, or the applications, depending on what your system you're running on. The types of data backups, well, you can back up the entire system, and typically you'll do that once a month or weekly. And then the rest of the time, since you don't want backups to take forever, you only back up what's changed since the last backup. Since the last backup means, okay, when I need to recover a file, I need to go get the full backup and then process the individual backups or the incremental backups since after that full backup. So it involves a little more of a procedure when you're recovering your files. I'll stop here and make one point that you don't really know a backup is working unless you actually go through the process of recovering a file. Do that to find out whether you actually have a backup. Now you could just have a conversation with your IT person saying, hey, suppose I lost this file, what would I have to do to get a new copy of it? See what they tell you. If they have a process, great for them. Often it's well, we'll have to think about that, and we're not sure. That would make me worry a little bit. There should be a good answer to when you say, hey, this file that I'm working on, can I get what would it take to get last week's version of that? Because I think I messed up. Or there was some information that we may need to recover. How could I get that back? Or just say, suppose my systems went down. How far back how many records would I lose? If they can say, well, we have everything backed up in the hour of things you've changed, that would be a pretty good answer. Then they could talk about full backups and incremental backups. Remember, you do fulls, and then incrementals are typically based either on the last incremental or since the last full backup. That's one thing you can do. Incremental, typically it's full, incremental, and then an incremental, what changed since the last incremental. And that would require you to do a recovery. Got to go get the full and then go through the whole sequence of incrementals to get to the one for your day. And it depends on your software, how it's doing it. So there's that restore process I just described. Restore the full backup and then either the incremental for Thursday or Monday through Thursday before getting to the Thursday versions. There are many backups, and of course you save those and you have some sort of policy of how long they're archived. We typically call those the archives as they get older and they're not the most current backup. You can back them up on your local computer. I saved my life in college. I had 2 hard drives on my computer, and back then computers weren't that reliable, and so I just made a habit of I just had a copy program that wasn't hard to write, took a little time the first time, that would just make sure I had a copy of all the stuff I was working on. It would make a backup copy to the second hard drive. Came in one morning and my hard drive was dead, and I was so happy. That second hard drive had all my college work, my thesis work. Just got used to, when you're in college, you get used to working on computers that are about to die, and so you just have that mindset of always having a backup. Now, they mentioned here that when I'm backing up on my local computer, I don't know if I'm following policies, if I'm backing up what I need to back up, and so someone wants to come and audit, am I doing what I'm supposed to be doing on my local machine? Well, it's typically a pain. They have to ask me to log out, come work on my machine, or they connect remotely to verify whether I'm backing up. But looking at local backup, typically you lose your machine and all your local backups are there, so it's not the greatest idea. Central backing up to some central location is the typical thing people will do, and it's often over a network storage device. Sometimes they'll perform the backups overnight when people aren't around, because often if it's going over the network, it's loading the network with quite a bit of data. If I'm doing it centrally, I can have a large storage, good deal on that large drive, cost per gigabyte is smaller. I can verify back at the admin office that it's happening, and usually they have a really stable storage of it, well maintained and documented what's been there, and that's typically the better way to do things. So you have your client with some backup console to the backup software running on some hardware. That's all it does, just store lots and lots of files. It could, as part of its backup, back up all the archives of mail from the mail server. Keeping that data protected continuously, like when you have active data that you need to recover from 2 minutes ago, you can basically mirror 2 systems, and that mirror is your continuous data protection. Software can be set up, the OS can be set up to actually automatically make copies whenever something changes, basically synchronizing 2 systems. Now there's lots and lots, as the internet has gotten faster, lots and lots of cloud-based services to back you up. Carbonite is one of them. You can use Google Drive. It takes a little more work. You can use OneDrive. You can use Dropbox, and basically install software that automatically does that backup. I have not heard of many people using mesh backup. Think of it as multiple computers sharing each other's files, and they have this idea of parcels being backed up to other client PCs, redundant storage, and they mentioned security as an issue there. I have not heard of anyone actually implementing mesh backup, but it sounds like an interesting concept, where each PC is sharing data with other PCs. Reminds me a lot of blockchain, Bitcoin kind of things. That's how that works. There's multiple servers out on the internet sharing with each other the blockchain information. Now we're going to talk about RAID, but first, the type of media. Magnetic tapes, they're still around. They do not last forever, but they are very cheap compared to hard drives. They are still in use. And typically they're used for the archival of data. You can use it for backup, and if you're trusting that you have a decent hard drive and tape drive, and you're willing to wait longer than average to recover a system from the tape drive, that's what you can use a magnetic drive storage. I have not seen many around. Run across them occasionally on old servers. I see an old magnetic drive reel in there, but a magnetic tape loader. I'm not seeing them as often, but still they're around, and very low cost per gigabyte compared to anything else. Optical discs, 6.4 gig per DVD hasn't increased a lot over the years because there's not the market for anything bigger, and partly because hard drives go in solid state as well as huge sizes at fairly low cost and very fast. Seems like people are happy to just pay for hard drives. But they do offer you some sort of capability. About 8 gig, you can compress some things. Pain is anything above that, which is becoming more common in files. You have to be swapping out the CDs. Sometimes you could back up your hard drive onto optical discs. They are more stable than magnetic discs, but still there is aging. Plastic does age, so they don't have a known age for CDs. Now, talking about RAID, redundant array of independent disks. Basically, think of you're storing your data on multiple hard drives, like I did in college. I made my own copy. I was basically doing a manual mirroring of my folder, constantly making a copy of it over to the second drive. They have a name for this. They call it RAID Level 1, where you're simply mirroring your data to a second drive. The nice thing about RAID is, once you have someone configure your RAID system, if they've done it, if you have the right kind of RAID system, you don't have to worry about it anymore. You just know you have a RAIDed drive system. To you, it just looks like you're storing something in a folder. But the computer is actually storing things to multiple drives through a RAID controller. So to you, it just looks like a folder. The system knows that when I put something in that folder, it actually goes to 2 places. And you never actually want to use RAID 0. That's just more disks. RAID 1 is more disks that are, say, some redundancy to my data. It's stored in 2 places or more. That's what we call redundancy. But again, it's done for you, built into the system. Hardware RAID, there's actually hardware and software RAID, but they're usually transparent to you. It's up to your sysadmin to install it and have it working. And it's basically putting your data in multiple places, and there are different ways of doing it to just make it recoverable, either faster or slower, and tolerating some sort of failure in the system. RAID is there for failure of the drive, not for archival. Backup isn't so much done, but your drive, you think of your drive as automatically storing data in multiple places. And it's nice if you can lose a drive and have it give you a little warning, but you don't have to rush in and lose data until you replace the drive. It will tell you it has lost a drive, but you can come in and replace it without even shutting down your machine. You can do a hot swap of a drive, and it will rebuild the RAID information into the drives. There's multiple RAID levels. Don't worry about memorizing all the levels. Just know there's a level that basically just gives you more drive space but really isn't doing anything redundantly. I would not even call that RAID because the R stands for redundant. Striping is not. Mirroring is a nice idea. Fairly cheap. Whenever I write something to a disk, it writes it to two places, and it does that for me in the background. And typically the hardware RAID can operate just fine. It can do the transfer speeds needed. One drive, no RAID, single disk. Think of it as a warehouse. I have one warehouse where I'm storing all my stuff. RAID level 0, I don't have multiple copies of my data, but I'm storing it in multiple warehouses. Well, one advantage of this, although it's not a backup, it does allow me to have multiple places to take the data away from rather than waiting for all the data and the server may be busy. So RAID level 0 is more of a distribute the data across multiple drives, but if one drive fails, you still have a big problem. RAID level 1, I'm storing it, making a copy of my data in multiple places, and so if one warehouse burned down, I can still get at the data. RAID level 5, I'm storing in multiple warehouses with backups in different places. And if one warehouse burns down, I can actually recover the data from that warehouse based on parity data and error data stored in different other places. There's a little example of recovering. I lose this, but I can recover the contents of warehouse 3 because I've stored parity information in other places. Geographically different location is very important for data backup. Creating your backup, you need to understand how much you need. Buy equipment that will meet your needs and scale to different needs. What kind of data do you back up? Do you back up everybody's downloads folder full of all the music they've downloaded? Well, have some sense of the policies that say you want to let people have some personal stuff, but you don't back up their entire collection of movies or music. Something that everybody overlooks is actually testing that you can recover the data. Doing that frequently. Where you store it, you're going to store your data in a data warehouse, locked doors. When you have your media, you have that tape backup. Where does that get stored? Typically there's cave systems. People build some storage thing. Do you have policies about encryption? Remember, I can encrypt data and lose my password to get at the data, and I've effectively lost the data. So make sure you have policies. And if you're storing tapes, better be encrypted, so if someone actually did grab that tape on the way to the warehouse, it would not be usable by anyone else. So good access control. Better have physical access control to where the data is. When I'm restoring something, there better be some kind of procedure and some kind of request process to go through restoring. You want to help the person that keeps losing their data to not have to need the restore services all the time. They're doing something wrong if they're constantly deleting their files. But if they're the boss, you just got to recover it. How long do you keep the data? There may be some legal requirements. Depending on who you're doing your work for, they may have some laws imposed on them of how long they have to keep data. Make sure you're checking in. Are you backing up? Are you following the policies that you have? Now with email, I'm going to kind of skim through this. If you're doing a lot of correspondence, your company is liable for things that were said in email, promises are made, or contracts. You better have some kind of paper trail for that, especially if you're going to get into some legal process. So, email, You can imagine that being a regular backup, and I would say, if you're doing the normal backup, you just have a longer archive period for all that email. And if there's some statute of limitations, make sure that you're able to meet the rules, the change in rules for how long and how far back I should be able to go in email. That could be information that you don't want others to get, so you want to keep that secure as well from other people getting it. You may have information stored on backup tapes. You should know what's on your backup tapes. Another reason to test, are you backing up what you need to back up? Are you backing up these huge files that you realize you shouldn't worry about anything over there in that public folder? Because I may need to prosecute, or there may be some audits, depending on the industry I'm in, there are laws about archiving data. If I'm archiving people's information, my customer information, you can be in big trouble if that data gets lost. So I recommend do not store customer credit card information. Use something like PayPal or Venmo or Zelle to let them deal with information that can get to bank accounts. But it depends on the law in where you're operating the business, what they require. There's various rules and procedures for recovering data and what needs to be stored. Some kind of store or protection of the mail data, that who's sending the data is authentic, that is them, they say who they say they are. And whenever I'm archiving data, remember, I can get at all the data if I'm archiving it, so there better be some protection on who can do the archive. You need some protection about the emails and what's been said. Damaged data, if there's one little change in the data, that makes the rest of it suspicious as well. Basic training about emails. Be business polite. Don't be full of sharing information that could be sensitive. Get people to understand that email is not private. Train them in watching for phishing scams. And remember, I guess one of the biggest things is remember BCC. If you're sending data to a large group, BCC everyone rather than giving everyone a copy of the entire mailing list. Be hard on people that don't do the BCC and practice it yourself. You can even explain in the email, if someone's not used to that, to say, hey, I'm doing this for security reasons and learned it in my class, and people will take it a little bit easier. There's spreadsheet data. You want to protect that as well. And of course, check that you can get the data when needed. Remember, you can protect data with macros. You want to be sure that you can get at that data if you need to change it before the person that wrote that spreadsheet leaves or goes on to the next project. You can actually store some files in a vault server. Never used one myself. Seems like a decent idea, just like the centralized backup. Okay, now getting to databases. They do a lot of technical stuff here. There's a database language is MySQL. It's like a programming language, letting you put in data and take data out of the database. But there's also other programming languages that can just simply ask the database for data and ask the database to store the data. So we're going to look at both the language of the databases and multiple other languages that interact with the database. So what do we want to do? Well, database, if you have a lot of data and want to get it fast, typically use a database. The database itself has its own security, login, and password protection built into all the data tables stored in that database. So think of it as another level of security. Don't use the same username and password as the Windows system. You can configure your database to just use Windows authentication, meaning if they're logged into my system, I assume they're that user that's logged into Windows. When you have other people connecting remotely, that isn't so meaningful. You have to have some limit to some things in the database about who the owner of that data is. If you shouldn't be able to change the data, maybe you shouldn't even be able to see the data. And you can build this into MySQL or build it into the programming language that you're using to retrieve the data. You've got ways of managing data. Microsoft Database Management Console is one of them. PHP MyAdmin is another. There are lots of ways to just make it easier to browse through your databases. You need to clean up your databases regularly. If the database software crashes, there may be messes left in the database that it realizes, hey, all this data is just garbage. We don't need to keep it. And you can have policies that make sure you know when data got changed. That's something that can be automatically set in rows of the database. Okay, getting to some details of database. Think of it as an Excel spreadsheet, but with special interface for other programs to get data out of it. You don't have to open up the spreadsheet. You just tell the database, I want what's on the row where I see employee number 4. Give me all that employee's information from your tables. You do have to know something about the structure of tables, but you don't have to open it like you would in Excel. You say, database, give me the information from the table with this name. Give me the line of it data that goes with employee number 4, 00004. And the database engine is very efficient at retrieving that data for you, bringing it back to you. So it's just called a fancy schmancy, very fast file information retrieving system. I can say, hey, if someone's logged into my system based on some type of either the department that I am in that's wanting to read the system, I can only change data for people whose department I am in. Now I can have a web page that checks what department I'm in and only allows me, when I want to change something, it will skip over anything that doesn't belong to me. There's ways of basically programming the database so when someone's logged in, they're logged into the database system, they can only make changes to specific things. We want to restrict access. Access to the database then is restricted to specific users that can only read what's in tables. Some users can both read and write. We want to make sure that someone trying to look at data in the database doesn't accidentally trigger think of it triggering a macro that goes and does something. So we make sure that the data coming in that we're entering does not somehow cause it to bypass. Remember, there's the data overflow. They decide to type in 10,000 characters from their keyboard to see what happens, see if they can crash the server. Or they type in the security key for that specific user. And what I've seen so far in databases I've been using is it'll come back and say, sorry, you don't have access to that data if you're the wrong person. Here's the kind of authentication you'll see in the management of the database. Don't worry about knowing this. This is the kind of thing you'll see in a database management course. You can set how your authentication. Do I have a separate username and password built into the database? Or do I use the Windows database to let me in? Well, Windows plus this gives me 2 layers of user password. Using the Windows database is more convenient, but I only have 1 layer of database access. We want to verify that only certain users can see the data, and that's something that the database language can be programmed to do. And it can be programmed as well to audit changes to everything. So you need smart database programmers to set up the macros to do all this. But once it's done, you want to see, hey, what changes were made today? I can go to the particular table, and it will have audit information about who and when the database data was changed. They call those triggers. I can actually have built into the database itself a trigger that will cause last updated data to be changed for that particular table. I can have macros run that send me a message, hey, someone just has access to this particular data. So it's like a whole programming language allowing fancy things to happen when I simply read or change the data. Usually I care about when data was changed, but you can actually set it up for whenever anybody reads a particular something, I get a message. Hey, somebody's snooping around in your record in the database, and it triggers the government to step in and see who's doing this. Just a little bit of a peek at what the language looks like for creating trigger code in a database. I have a name for my trigger, and when I see here it says when the employees table gets an update, I declare some variables and check to see is the data being updated. If it is, I will store some information, or in this case send an email that hey, some data is being changed in your very special table. When you're providing a web page for your corporation, typically you have the database website software, and you've got database middleware that gets data and stores data from different types of background processes, and then a database actual server that's simply taking that data. Many times you can combine this all on the one machine. But in a huge corporation, you may have your web server with all your customers coming to making orders. Those orders may be going through 2 other servers. To the customer, it looks like it's all on your web page. Another way to protect your data, if it were stolen, you have it always encrypted in storage. So unless someone has your secret keys, your data is not encrypted. Now the danger of this is you're going to forget the encryption code, and as much as you hate to write it down on your desk, storing that in a secure place, names of tables, users and passwords, may save your life to be able to actually get at the data. You can lock yourself out of the data. If it's secure, you should be able to lock yourself out. And of course make sure it's more than one person that knows where those keys are. So if I lose the key, bad things can happen. I can have big long time to try to restore my database. So their advice is keep your escrow key, central key, escrow on the corporate server. What are you going to encrypt? Either in the database or in your system. Well, the well-known files that you don't want someone to see. Or you could just say enable encryption, and the system itself knows how to retrieve all of the information, including the programs on your system. You can retrieve all of it. Typically, you tell it what you're protecting. You don't need to back up everything. When I'm sharing files with other systems, it's very convenient to be able to get at files from other systems. That is a network security hole. I can bring in a file to a system that's behind locked doors as though I'm sitting there at the desktop. Many people don't realize that. And file sharing is something like that as well. You can share files with someone. Microsoft has gotten a little bit naggier about when it sees files that are shared, it will warn you. Are you sure you want to do this? Now remember, we have our data loss prevention, basically going over various concepts dealing with preventing data being released to unauthorized persons. You separate the data out. Anything that's personally identifiable isn't in the same database that it may possibly get stolen. You only have information, you don't have who it's tied to. Now, someone may be smart, be able to guess who it's tied to in your table, but keeping yourself a little less liable for attack by not storing personally identifying information. You basically keep it in separate databases or separate files. You encrypt it or some way obscure the data. You store the data by, phone number with some mathematical formula attached to it, a reversible formula, so you can always get the phone number back. So, data you may have in 2 different tables, the stuff that you may share about things, you may think it's innocent, but could that information be used to actually find more about the person if they have these they have the intersection between two tables, between medical data and voters. This kind of thing is very valuable if there's a big medical issue in the politics. Well, the people that want to make the best money for what they're paying for people's phone numbers, that it is properly filtered data that won't get them in trouble. This idea that if I have some information about a person, I might be able to locate them more ideally based on what the state of the program is in. If I had software on there that would allow me to get at the data, even without compromising the entire database, that would be a good piece of hardware. So the idea here is if I know some things about a person, I might be able to triangulate and to know, hey, when I saw this person out on Facebook, is it really them or not? Well, based on what I know about their details, it's not matching my triangle. You have data in the database, restrictions there. You have file permissions on files on your computer. And 13 levels of permissions in Windows, 2 levels of permissions in Linux, read or write. This came up, people were illegal copying videos. They decided to put digital right management chips actually in recorders. People were all up in arms about that. But the idea was, I don't copy things that don't have the digital rights management codes in them that I only can get by purchasing something. They're trying to use it for music and video, but I haven't seen it being enforced. College campuses are notorious for hacking, and people don't feel bad about just making copies of things. Well, this is one big way they tried to prevent that. I'm not sure how well it has worked. For your corporation, do you want to know not only on your network, but how physically could data go in and out? How could they get data out of that server? Are there USB drives that are not disabled? I could walk up to that server and slip my jump drive in there and come back the next day, or wait 5 minutes to take it out. I might have lots of data. Are policies in place to not allow that to happen? Extrusion is data leaving the company through various means, and that's part of your data monitoring, network monitoring. There's a lot of outgoing data, more than normal today. Well, where is that coming from? Jump drives and other ways of removing media is a way of stealing data or damaging data. Have some policy on that. Some policies, just because people insist on using jump drives or their phones, you may not want to disable cell phones when they come in their building, but have some way of them knowing that's not a particular thing to be allowed to do. So here's your data loss protection, multiple levels, watching the traffic going in and out, check for policies, what's allowed out, see clients and encrypt it for customers, for getting transmitted, and when it's stored, I have some way of encrypting it. And when I need to get at the data, a decent way of extracting it without a Supreme Court order. General ideas about not letting data out. Don't talk about sensitive projects on blogs. It's so easy to let a word slip here or there, and they can do that triangulation and figure out what you're working on just based on what you've talked about for the last month. Don't talk about marketing campaigns. People can know, I'm going to ignore that mail from that company because I know they're starting some marketing campaign. Don't say bad things about products. Just refrain from saying things. The worst you could say is, I'm not using that product. But don't say why. Not sure how well it goes with cosmetics. I'm assuming you can say, didn't work for my skin. Don't want that particular product. But don't give away or say nasty things that could get you fired, or have someone sue you for saying something bad about their product. Be cautious about what you post. Remember that what goes on social media stays there forever, and they may want to hire away good employees or not hire you because what someone said you said on the internet with some legitimacy. There's going to be some fake stuff out there, and good employers will know how to filter through that. If you need to destroy your data, like get rid of your computer, remove the hard drive, erase it, or shred your hard drives. SSDs and other things that don't so much look like hard drives. You may have a SSD right there. It looks like just like a big chip. Make sure you know what data is storing things. Can't store a lot of things in BIOS, but there's some possibility, I would suppose. When you're deleting things actually don't get deleted. You're only deleting files from the list of files on the computer. To actually delete the data, you actually go through a replace old data that's freed up. You actually write to the disk zeros, and you can't just write it once. You have to wipe it multiple times because those little magnetic signatures persist, and people can possibly recover what you have on the disk and steal your data. So to delete using the delete key, well, it typically goes to the recycle bin. You want to make sure it's not recoverable necessarily. You empty the recycle bin. You choose to not restore the recycle bin. You clear out the actual data on the disk that you want to be sure is not there anymore. Remember, when you delete a file, you're just telling your computers, don't keep this location of the file, don't keep track of that data anymore. Erase the file entry, but the actual data wasn't erased out in your hard drive. You can have your systems not only delete the connection to your file, but also delete, wipe zero, clean it of the actual data that was stored. So, that was Chapter 9, Data Protection. Quick time through those concepts. Main thing to remember is have an idea of what RAID is. That should be something in your system. If there's valuable data at all, it should be stored. And the RAID, think of the RAID as automatically backing up things as you write. But then also having manual backup policies in place. Review them, be able to audit them. Okay, have a great day.